Hi everybody, welcome to this video. I finally got around to making a revision video for the mid-year exams. So let's get started right away. So mid-year exam, 2-hour paper, always starting with algebra. Your paper 1 will always start with algebra, and it will be about 20% of your question paper. So the first one was actually very easy. We have an equation equal to x. It's very easy. X plus 3 squared is equal to 9. So there's different ways you could have gone and solved it. You could have multiplied it out and then just got a quadratic equation, but what would have been easier was just to take the square root on both sides. So taking the square root on both sides, always remember, then you get a plus minus square root of 9, and that's where most people lost their marks, so that you get two answers. You get either x is equal to 0, or you get x is equal to negative 6. So if x was plus 3, then the negative 3 makes 0. If x is negative 3, it gives me negative 6. And so those are 2 marks just simply for the two answers. Okay. The next one is was fairly easy. So it was simply, I think everyone got that one correct. And it was simply writing it in standard form. And usually when you see this rounded to decimal places, you know you're going to use your formula. So if we go back there, so remember that question. So 3x minus 2 squared is equal to 5x. Okay. Yep. And so simply multiplying it out, getting it simplified, x squared minus 4x plus 4 is equal to 5x, leaving us with 3x squared minus, and so this is going to be negative 12, negative 5, so it's negative 17x, and then plus 12 is equal to 0. So we substitute this into our formula. X minus b is already negative 17, so negative negative is positive 17, plus minus the square root of b squared, that's 17 squared, minus 4 times 3 times 12, divided by 2 times a, which is 6. And if we calculate that, we have 17 squared minus, this is 144, is equal to 145. So the square root of that gives me this square root under there, that value. So that's what I'm going to store in my calculator. I store it in my memory, and then I'm going to say 17 minus, recalling my memory, divided by 6 gives me 0.83. So x is rounded to 0.83, or, and then my other value is 17 plus memory recall there, divided by 6, giving me my 4.84. 4 should say x is roughly equal to 4.84. There we go. That was simple as well. Then here is another question that most people actually did fair with, but in this question we see we have a square root that needs to be solved, and here's what the major problem is with people solving the square root is they just square right off the bat. So we've got x plus 12 minus the square root of 24 minus 10x is equal to 0. And so people just square immediately. Now the problem with squaring immediately is you're going to still have a square root. You can't just square every term. You have to square both sides. So what makes sense, and not what makes sense, what you should do is always get the square root on its own. So on one side should just be the square root, so that when you square this side, it cancels the square root. If there's anything other than just the square root, you will have, for example, if I have a plus square root x times b. If I square this thing, I get a times a is a squared. Then I get a, those two terms multiplied together, two of them. So 2 square root x ab. Plus, now when I multiply this by itself, I get x square root x times square root x is x, b times b is b squared. So notice that if I have anything more than just a square root term, then when I square, I'm going to have another term that still has the square root. So that's why I get it all by itself, and then when I square the left, I must also square the right hand side, so that I get x squared plus 24x plus 144 is equal to 24 minus 10x. Let's make sure I got it right there. Yes. And so now I'm left with x squared plus 34x, and then the 144 minus 24 is 124. So what can I multiply together so that I get 34? Okay, you can obviously use your calculator, but what would give me 34? Well, how about 31? 41 times 31 times 4 gives me 34. So 31 times 4 will work, but 31 plus 4 is not equal to 34. Okay, so let's try. Okay, but I see I made a mistake here. Sorry about that. This is 120. Okay, so 144 minus 24 is 120. Sorry about that. So if I what times what gives me 120, that's 30 times 4. So x is equal x plus 30, x plus 4 is equal to 0. And so now I see, okay, so x is equal to negative 30, or x is equal to negative 4. Now, from the beginning, from when we get to the end, you have to understand that initially we did not have a quadratic equation. This is not a quadratic equation. So it is not likely that we will have two answers, but we did get two answers because we made it quadratic. We squared both sides. It's like saying x is equal to 1, and then I square both sides, then I say x squared is equal to 1. Well, x squared equal to 1, all of a sudden x is equal to 1, or x is equal to negative 1. So the moment you square both sides, you are giving an extra solution. So in order to solve that, we have to go and test which one won't work in the original question. So here we can see, well, that isn't part of the original description. So here we can test. So for example, if you put in the negative 4 up in here, you get 24 minus, and then 10 minus 24. So let me just show you here. 24 minus plus 10 times 4. Oh, you can't see there. Sorry about that. Okay, that gives you 64. So the square root of 64 is 8. Okay, negative 4 plus 12 is 8. So this gives me 8. That gives me 8. 8 minus 8 is 0. So this one works. Okay, but this one, notice what happens when I put this one in. Negative 4 plus 12 gives me negative 18. On this side, 24 minus plus 10 times 30. This is 300 and 24. Is it? Okay, just make sure. 24 plus 10 times 30. Okay, 324. The square root of that is positive 18. So the square root of that is positive 18. And the problem with that, all of a sudden, is that now negative 18 minus positive 18 is also 0. No, I lie. Negative 18 minus negative 18 is negative 36. So notice here now this is a negative answer. Instead of with the 4, we got a positive answer here. This one will always be positive. So if we are subtracting a positive, we can never get a positive, a negative answer that I can subtract and then get 0. So that is why in this case this one is not applicable. Yes, it is a solution to the question, but it is not applicable to this specific question. Okay, those 5 marks, let me just show you how the marks are allocated. So first of all, we allocate a mark for solving the square root. That is part of the normal procedure when you have a square root in an equation. So we give you steps for marks for every normal procedure step. Then we give you a mark for squaring both sides. Then you are given a mark for getting it into a standard form, okay, or for the factors. It depends. Maybe you skipped one of these steps, but you have the factors. Okay. Then we give you a mark for both answers. So you should get 4 out of 5 if you got to this step. But the final mark is given for noticing that this one is not applicable. Okay. So to get 5 out of 5 marks, you have to test your final answer, which I don't know if anyone did that. Okay. This question could be done in a variety of different ways. I think I had at least 4 methods on my memorandum. So I'll just do one of them, the standard one. So we have 81 to the power of x plus 1 to the power of x divided by 27 is equal to 1. Okay, now whenever something divided by something is equal to 1, it just means that that thing is equal to that thing. So, or you could have just said, well, multiply both sides with 27. So what we're going to do whenever we have a base and exponent pair, so we have a base and our unknown is in the exponent, what we want is a base exponent equal to an answer. Okay, now what we would therefore like to do is to get all the base exponent pairs on the one side and everything that doesn't have a base and exponent, an unknown in the x on the other side. So multiplying by the 27 makes sense. Now what we can do here is here we are applying an exponential law. A power with a power, we multiply the exponents. So it's 81, and then we've got x squared plus x is equal to 27. And now there's a variety of different ways that you could have used it. You could have used logs. Okay, could have said log of base 81, and then inside here is the answer 27 is equal to the exponent x squared plus x. That was one way you could have done it. You could have also tried making the bases the same. So this is 3 to the power of 4. Now that exponent must multiply the existing exponent. A lot of people forgot to put brackets there, so they just had 4x squared plus x. But the bracket is important. This is going to have to be distributed, is equal to 3 to the power of 3. Okay, so what we get in the end is this 4x squared plus 4x is equal to, so what we're doing is, since the base on this side is equal to the base of that side, it means that the exponents must be equal. If I've got this thing equal to that thing, then surely the exponents must be equal as well. So if the bases are the same, so that's why I get that. And again, I get a quadratic equation to solve. And on this side, it is exactly the same. The only difference is that your calculator answer should here give you a 3/4. So that in the end you have something like this. Now if I multiply everything with a 4, I'll get also to this expression. Just when I have a fraction in an equation, just multiply everything with the denominator to get the final expression to simplify. And so this simplifies simply into 4x minus 1 and then x plus 3. Let me just verify. I'm going to keep this. One of them has to be a negative. I want the biggest one to be a positive 4. That looks wrong. I think this has to be a 3 as well. This. So x minus 1 is equal to 0. I want the middle term to have is a 2. Trying to work it out now. Okay, sorry about that. This one I think has to be a 2. Just use your formula if you can't do this. There's no reason why not. 2x plus or minus 3, and then the other one must be x minus 3 is minus 1, okay, is equal to 0. Now one of them must be positive, because a negative and a negative will give me positive 3, so I just have to figure it out. So this is negative 3. Oh, sorry, that also must be 2. This is because 2x times 2x must give me 4x squared. So this is negative 6 and negative 2. So I want a positive 4. So I want positive 6, negative 2. Great. So I get 2x is equal to 3. So x is equal to, to negative 3. So x is negative 3 over 2. Or x is equal to half. If I solve this, both of these will solve this original equation. I don't have to go and test it, because originally I did have 2 equations. I didn't change anything to the type of equation I had, except for losing the bases, but originally there was a quadratic unknown in the beginning, so I don't have to go and test that. Okay, the next part of the question is consider the equation of x squared plus there. So they give us an equation with an unknown value. We would expect s to be some value. And they say if s is 6, what is the nature of the roots of an equation? Now, nature of roots is almost definitely going to be a question in your final exam. So just get along with the program. Nature of roots is all got to do with the discriminant, which is the b squared minus 4ac. If the discriminant works out to less than 0, then we know that the nature of roots are non-real. They're not really roots. If the discriminant is equal to 0, then I've got one rational root. One rational root. And if it is greater than 0, I have 2 real roots. Not rational, but real roots. Now, if I want the 2, if my discriminant is equal to some number, some square number, in other words, something like 4 or 16 or 25 or even 1, 4, 16, 25, 36, any number that is something squared. Oh, I've got 9. Anything like that. Then I will have 2 rational roots. If it is not equal to something squared, okay, like 5 or 10 or 20, then I get 2 irrational roots. Irrational roots. So remember that rational and irrational together makes real. So anything bigger than 0 will give me 2 roots, 2 distinct, 2 different roots, meaning that in the expression ax squared plus bx plus c equal to 0, if I use the b minus 4ac and I get something that is less than 0, this thing doesn't have solutions. If I get something that is real, I'll get an answer and another answer, but the two answers will be exactly the same. So in other words, I will have one rational root. If I get it greater than 0, then there's two possibilities. Either it is two answers that I can write as fractions, okay, like the ones we just saw here. Those are two rational roots, distinct but rational. Or if the discriminant is not equal to a quadratic, and so let's just test it here, for example. So here we get 16 minus 16 times negative 3. So it's 16 plus 16 times negative 3 is 48, plus 48 is equal to 64. 64 is 8 squared. That is why I got two distinct rational roots. Now if I go up to this question where we used our formula, these are irrational roots. They didn't have a comma that repeated itself, or a rational pattern after the comma. Now look what happens when we get the discriminant there. We get 17 negative squared minus 4 times 3 times 12. Okay, that's what we got inside here. That's what I calculated, and I took the square root of it. Now if I take the square root of this thing, it is an irrational number. So when I have an irrational number, adding it into a fraction will still just give me an irrational number. So that's why when I took that, it gave me an irrational number, and that's why my roots were irrational. So if I can't take the square root, in other words, the discriminant is a number that cannot be rooted into a pretty number, if I can use that, then obviously I will have two irrational roots. Now, just with that being said, they now then give me a value for s. And so they're not asking me to solve the equation. They're saying s is equal to 6. So b squared minus 4ac is then equal to 6 squared minus 4 times 1 times 9. So what do I get? 36 minus 36. So I get 0. So a lot of people gave me the answer, and they gave me one solution, x is equal to 3. But that's not the question. It wasn't what is the solution. The question was, what is the nature of the roots? And in this case, the nature of the root is this, one rational root. The next question now asks me, for which value or values of s will this equation have two unequal real roots? So I want two unequal real roots. So just this, I just want my discriminant to be greater than 0. So how will I do it? Well, what's my discriminant? b squared minus 4ac. I want it just to be greater than 0. That's the only condition. So b is unknown. It's the s value that I don't know. Minus 4, a is 1, and c is 9. Is greater than 0. So I get s squared minus 36 is greater than 0. This breaks into two equations, s minus 6, s plus 6 is greater than 0. We know how to solve this. This is a parabola, two roots, one at negative 6 and one at 6. I'm looking at the part of the parabola, the root, the part of the graph that is greater than 0. So I am making use of this part. Okay, it's the parts of the parabola that point away from the intersections. So one is pointing towards negative infinity on the x-axis. Sorry, negative infinity on the x-axis. The other one is pointing towards infinity on the positive x-axis. So in other words, our two solutions is that s is less than, and it doesn't include it because it never included it there with an equal sign. It doesn't include it. So when s is less than 6 or negative 6, or when s is greater than positive 6, then this equation will just have two rational roots. Now it can be two real roots. Now it can be rational or irrational. That wasn't the question. Just asked for two real roots. And there we go. That was in 25 minutes with explanations, question 1. So if you have 2.1 minutes, 1.2 minutes, that's exactly how long it should have taken you to do question 1. And I've included explanations. So definitely, if you know your work, let me just quickly explain to you what levels these were, things that you should think about or not. This was a level 1 question, which means you should just be able to write down the answers immediately. This was a level 1 type answer, because you should just be able to do it, applying the formula without having to think about it. You should know exactly what to do in this question. This is a level 2 to a level 3 type question. I think I assigned it as level 2 because it's a standard routine procedure you've done since grade 11. Get the square root by itself, square both sides, solve the thing, and test the final answer. Standard routine. This is not standard routine because there were some various applications. So I did say this is level 3, but definitely an easy level 3 question. Level 3 just means you applied more than one topic in order to get to the final answer. It is complex procedures. There was a step and then another step and an in-between step, things like that. Okay, but still not a difficult one. This one here, this one once again was just a routine procedure where you use the formula, you find the value for the discriminant, and you interpret that value. So that is standard routine procedure. This one, however, was maybe somewhat more complex, where you exactly what we did here is we did use our theory, but the use of our theory then involved the solution of a inequality, a quadratic inequality. So again, there's some nature of roots question, but in getting to the answer we used a quadratic inequality, and so we have different topics in one question. So that's level 3, and in your exam you'll have 20% level 1, 35% level 2, which were basically these 3 questions, and then 30% level 3, which were now these, and then level 4 would have added up to another 10%, but there wasn't a level 4 question in question 1. Well, all of that for question 1, and it's going to take me another 3 videos as I do question 2, 3, and 4. Okay, look out for them. See you guys later.